Hello, everybody. Thank you for joining us here today at the Emerging Media Lab Showcase. I'm sure more people will be filtering in, but let's start right on the dot because we have a pretty heavy agenda. There are so many projects to look through. So I just wanted to say hello and welcome to the showcase of all of our projects our teams have worked on throughout the spring and summer terms. Thank you for joining us at this busy time when we're all trying to navigate online teaching and learning. My name is Sam and I'm the digital media storyteller at the EML. It's my honor to be your host this afternoon and to guide you through all of the exciting things that we have to show you here today. So first off, I'd like to acknowledge that we are on the traditional, ancestral, unceded territory of the Coast Salish people, wherever you're located in the Lower Mainland and beyond on the West Coast. And though we are not all on campus, I'd also like to acknowledge that our Point Grey campus sits on Musqueam territory. Even though this event is online, it's still important for us to remember that we live and work on borrowed land. So before we get started, I just want to make sure we're all on the same page about a few housekeeping points. This meeting is being recorded to be posted on our online channel, so please keep that in mind. Feel free to write comments and interact with others within the chat box. There is a function at the bottom of your screen that should say chat and has a little chat bubble there for you. And please put all of your questions into the Q&A function at the bottom of your screen. So please don't put that in the chat box. Your question will get lost in the wave of different things that is getting filtered through. You may comment on and upvote questions that you would like to be asked. There's that ability in the Q&A function. There will be 5 minutes after each presentation to ask a direct question to a presenter, so you can use the Q&A function, or you can indicate during the question portion of each presentation to Jennifer Fan, our lab coordinator at EML, in the chat box that you would like to be unmuted. I believe you can actually raise your hand to be unmuted. And for all of our speakers today, a friendly reminder to turn off your mic and video when you're not presenting and to turn it back on when you are to make sure that the correct presenter is visible on screen. And a quick tip to everybody, if this is something you'd like to do, you need to do something a little more technical. If you go to your video settings, you can enable hide non-video participants so that the person speaking is more visible. Now let's get started. So we start this showcase in memory of our late colleague, Kirk, who acted as the EML supervisor before he passed away on March 9th this year. May he rest in peace. We have dedicated our third space in the Westbrook building in his honor. The K. Harrison Collaboration Space is our newest space on Point Grey campus, which was created under Kirk's supervision. Kirk was a bright light at the Emerging Media Lab, and he will always be missed by all of us. To kick off our showcase, we'll be starting with 2 opening speeches from UBC's Chief Information Officer, Jennifer Burns, and the Academic Director for the Center for Teaching, Learning, and Technology, Christina Hendricks. UBC IT and CTLT have helped to shape EML, and we're extremely appreciative of their support over the years. I would like to ask Jennifer and Christina to share a few words before we begin project presentations. So first up, I'd like to introduce Jennifer Burns, Associate Vice President, Information Technology and Chief Information Officer at the University of British Columbia. Reporting to the Provost and Vice President Academic, Jennifer provides leadership in ensuring the institution's digital capabilities meet the needs of UBC's teaching and research community, as well as identifying opportunities to deliver efficient and effective administrative solutions. During her time at UBC, the Emerging Media Lab was launched, working with faculty, staff, students, and commercial partners to use augmented and virtual reality in the classroom and for research. As well, UBC has undertaken strategies to advance a vision of a digital future, supporting the implementation of its strategic plan. Jennifer views technology as a strategic enabler to the university's vision of creating an exceptional learning and research environment. Her work as the CIO is guided by the values of integrity, transparency, collaboration, and excellence. Here she is.
Hi, thank you, Sam, and welcome everybody. I really appreciate the team having invited me to the annual showcase, which is obviously one of the highlights of our fall season. Normally we get to do this all together, but I think it's fantastic that the team obviously has found a way to do it in an online environment. The Emerging Media Lab has celebrated yet another really incredible year of success with its community of faculty, students, and industry that really look to explore new technologies and innovate new ways of thinking and playing and becoming co-creators in the educational process. For me, the Emerging Media Lab is one of the jewels in the crown. We think about ways that we innovate in teaching and learning. So we have things like the Emerging Media Lab, we have the Amazon Kirk. We're fortunate to have, the Center for Teaching and Learning Technology, which does such an amazing job of supporting faculty in finding ways to teach, and also in bringing in students into the equation, and then also looking at exploring those new technologies. And it's a real critical for me that in this, IT can be partners in the success of all these different units. And one of the things that I love about the Emerging Media Lab is that partnership between faculty and staff and IT and teaching and learning, and then also the broader community in finding new ways to do things and supporting one another. It's absolutely wonderful to see, and I look forward every year to seeing what the outcomes are. And the EML really began 2 years ago with a really direct connection to that strategic vision of transformative learning. The fact that we've been able to enhance that, to add other locations, and to go virtual is really a testimony to the commitment that UBC and all of you have made in investing in technology spaces as part of the essentials of learning. One of the things that make it happen, of course, is the support from UBC, but it's the passion and the dedication of everybody involved in making these projects work, in trying new things, and really succeeding in the way that we have innovated. And this is really an important showcase of all of those things that have been done, because it allows us then to think about what's next and what other ways we might do that. And that's where I think the importance of the EML being for everybody. So last year, when the EML opened its location in the Ike Barbara Learning Center, Saeed remarked that the EML and the library share the same sense of inclusivity, and it's a gathering place and catalyst for ideas and multidisciplinary collaborations. And that's more important now than ever, since we're all together but apart. And so being able to continue that journey over the next year coming is really critical as well. So I look forward to seeing how that evolves in our new world. At a time, for right now, where we're really reliant on technology to be able to connect, it's really important that EML is there not just for academic enrichment, but also for the personal enrichment and career growth for our students. And it's an important part of the process that we engage with our students and enable them to participate in these projects, because it's, I think, a way to be able to provide those skills and learnings that will take them into the future. And I know as a CIO that the interest in the Emerging Media Lab goes beyond UBC. It's certainly made a name for itself in the community and also in the higher ed community across Canada. We've seen the granting of awards, so the recipient of the Cuccio Innovation Award, which really recognized the innovation among higher ed institutions. For projects such as the Holobrain and ScholarsVR, they've been featured in news stories and publications, and the enthusiasm that drives this forward is the many project leads and, frankly, the storytelling of USAM. And so that's amazing that we continue to be able to tell the story of the EML, because as important as the work that we do is that people know about it, and so that it builds in a virtual cycle. So these accomplishments would not be possible without the leadership of Saeed, the many staff and faculty and students who've made the EML so valued and appreciated. And I've really enjoyed over the past years being able to meet them and see the enthusiasm and see the importance of it to both the faculty and staff. And I'd also like to acknowledge the significant contributions of Kirk, who was the acting supervisor before his passing away. And I'm glad to see that we're able to recognize that in a meaningful way by renaming some of our spaces. I know Kirk made a big impact on UBC and on his colleagues. and that we can continue to recognize that going forward is great to see. Everybody that I know who talks to me about the EML, who asks me about the PML, there's always so much pride in the work that's done. And I hope today's events will leave you with the additional knowledge about all that the EML has to offer and how you might get involved as well if you're not already. So thank you, everybody. Unfortunately, I can't stay. There's some other demands on my time today, but I hope to be able to pop in and catch up from time to time throughout the session. Take care, and we'll talk soon.
Thank you so much, Jennifer. Before she leaves, thank you so much. Your words really mean a lot to us here at the Emerging Media Lab. I can say that confidently for all of us. But here also to say a few words is Christina Hendricks, Professor of Teaching and Philosophy at UBC Vancouver, and also the Academic Director of the Center for Teaching, Learning, and Technology. She helps guide the CTLT as it provides leadership, academic services, and support to the teaching and learning community at the university in many different ways, including in the areas of teaching practice, professional and resource development, program development and curriculum renewal, pedagogical and technological support, and learning technology support and development at the institution. Christina is also the director of the Institute for the Scholarship of Teaching and Learning at the CTLT, which provides resources, workshops, and other assistance for faculty doing research on effectiveness and impact of teaching practices and learning activities. So if anyone's interested in researching how emerging media projects may improve student learning, please let her know. Here's Christina.
Thank you very much, Sam. I'm excited to be here for the annual Emerging Media Lab Showcase. I look forward to this event every year. And as Jennifer mentioned, you know, we often have it in person, and I remember in past years being able to try stuff out, you know, some of those wonderful VR things that you can put on the eye thing and the hand things, and I'm obviously showing my lack of knowledge about what they're actually called. But I'm excited to be here. I'm inspired, as Jennifer mentioned as well, I'm inspired by the innovation process at the EML, with the permission to fail being built explicitly into the process, promoting risk-taking, allowing for the implementation of creative ideas into practice, some of which may not work and some of which do, but we might not have ever known that until things were tried out. And that permission to fail, to me, is really an inspiring way to think about innovation and creativity. And also, as Jennifer mentioned, I really appreciate the deeply collaborative approach in the EML with students, staff, faculty, industry partners, all working together and learning alongside each other. And as a faculty member who's thought quite a lot about teaching and learning, clearly having the student voice and the student perspective so directly involved in designing projects like this, I think is really valuable, so that their experiences as learners in classes are really built deeply into the way that the projects are designed and put into practice. At the Center for Teaching, Learning, and Technology, we also believe that emerging technologies and immersive media play a really important role in enhancing teaching and learning. And we're happy to showcase EML projects through our website, through stories, on our website, newsletters, and social media. I'm excited to learn about these projects, and we're happy to share them with other faculty members who might be able to use them as well, and to promote the EML itself amongst faculty who may like to get involved. And particularly, I think in the current environment where so many courses are online, we're really interested at the CTLT in learning about and sharing with others innovative, creative, exciting digital projects and tools that can be used in teaching and learning. We've also collaborated with the EML in a couple of other ways over the past several years. We've supported student learning technology rovers to help with the EML's Irving K. Barber library space over the past year. A number of projects in the EML have received funding through the Teaching and Learning Enhancement Fund, which we collaborate with the Provost's Office to facilitate and support. And the EML has received some TLF funding to support the purchase of some equipment. So that's really fantastic. I'll just end by saying we look forward to collaborating further. So I'm really interested in thinking about how we can help share the really innovative projects and ideas around teaching and learning that are coming out of the EML, and how we can spread those projects to practice in teaching and learning in the rest of the university. So I'm excited to see what new projects have been happening in the EML recently and over the course of the rest of this event. So I will be here and listening carefully and watching to see what's going on. Well, thank you very much.
Thank you for that, Christina. Yeah, I've personally worked very close with CTLT in the past, and I'm so grateful that they've been supporting the EML this whole time. One of their LTRs, Hannah, actually has become one of our work learns now. So thank you for her. She's so great and talented. And the EML looks forward to working with the CTLT in the future as well. So let's begin with the project presentations. First up, we have Real World Digitized Spaces presented by EML's lead developer, Dante Cerrone. So take it away, Dante.
Hi everyone, my name is Dante Cerrone. I'm working as a software developer here at EML, and we're going to kick off the project presentations with the MainML Hustle project. Now, this isn't necessarily our newest project, but this was a good opportunity for us to wrap things up, display what all the efforts that have gone behind the project, and also to honor Kirk's memory. Since he was, as I'm sure a lot of you know, a big influence in this project and a whole lot of others, so I'll get started. So the idea and the goal behind this project was to get a hand in figuring out how we can turn our surroundings into virtual spaces. So in the image that you can see here, the bottom part is a representation of what it looks like inside of the application, and then at the top is a real picture of MainML Hustle. So you can see that there are some similarities. Obviously, they're not the same, but we've seen that it does provide somewhere close to what the real MainML looks like. So I'm sure you can all imagine that the ability to represent real world spaces in a digital application can have applications in many different contexts. And so the idea was for us to figure out how we can do this and to develop some experience in producing this sort of visualization. So this project has been active for a couple of terms now, so I'm listing two different project teams. For the winter term 1 2019 team, they worked on, and I'll describe it a little further on, but the initial development of the 3D models and putting them into a Unity project. And then for the following term, we took the efforts and the models and assets developed from that team and turned it into a web-focused application. Right. So a few of the modeling techniques that were used for the development of this project, there is a Blender plugin called Blender OSM. And actually, I didn't know that this technology even existed before I started working on this project. But what you can do is take map data, and this plugin can export 3D models that represent the buildings within the map data that you provided. And so using the 3D models from this data, we developed a workflow where we take images from the buildings that we want to represent and turn them into textures for the 3D models using Maya and Adobe Photoshop. And then finally, we put everything together in an interactive 3D game where the goal is to start from one end of MainML to the other end and try to make it to class on time. So due to some concerns when it comes to the contracts that you have to fill out when publishing to different app stores, we weren't able to get the original application out to the app stores, but then that also gave us an opportunity, and now I'm talking about the efforts that were put into the project for the second term. It gave us an opportunity to pivot into a more accessible way to distribute this sort of application. And so the decision was made to transition the assets that were developed for the original Unity 3D game into a WebVR application. So this kind of enforced or furthered the original goals of the application, which were to get experience developing this sort of 3D space, digitized 3D space visualization. And so we got the opportunity to flex our muscles a little bit in this area as well. And we found that there were some benefits to publishing to web. This being that publishing to web doesn't depend on third parties for distribution of the application, and also it makes it much easier to access an application. So after the efforts that were put into the project for these two terms, the final results are after some internal testing, we realized that the models that we were producing and the textures that we were producing for those models needed a little bit more optimization to be able to be super effective on the web, but that is definitely something that is within our reach to do. And so we've documented the workflows that we use to create these models, and the WebVR implementation of main Hustle is available at this link if you'd like to visit, just with a caveat that you might need a slightly stronger machine to be able to see the application in its full glory as it's not fully optimized yet. And yeah, this project is dedicated to Kirk. He embodied many of the values that are important here at UML, just to mention a couple: creativity, experimentation, and collaboration. I got the massive benefit of working closely with him for a couple of months while he was acting supervisor at UML, and he taught me a lot during that time, and I miss him dearly.
Thank you for that, Dante. If anybody has any questions, this is the time to raise your virtual hand, and you can, we'll unmute your mic and you're able to speak directly to Dante. Otherwise, we'll move on to the next presentation. So I'll just give a minute here, maybe like 10 seconds.
Yeah, just to clarify a little bit about the nature of the game that we were trying to produce. As I'm sure a lot of you who are familiar with UBC know what it's like to get from one end of UBC to the other through main mall, and how busy that street can be. So the idea of developing the game in that sense was to provide people who are unfamiliar with UBC a little piece of what the culture is. So that they can understand, oh, that this, when they get back to, or when they end up actually visiting UBC, they can see that what the original game was trying to describe.
All right, so if there are no other questions, let's move on to the next presentation. So next up, we have Metabolism Visualized in Networks, presented by the Principal Investigator, Lindsay Rogers, Nico Dumriek, and Dante Cerrone again.
Yeah, so it's me again. The background for this project a little bit, actually, I'm going to hand it over to Lindsay Rogers now, because she is the principal investigator and is familiar with the subject matter for this project.
Okay, thanks, Dante. As Dante said, I'm a teaching faculty member from the biochemistry department. So just to kind of put some context around this project, I'm just going to start by giving you a little bit of background or explaining a little bit about metabolism. Assuming that some of you aren't biologists here. So we define metabolism as all the chemical reactions that occur within a biological system. So we could say all the chemical reactions that occur within an individual cell in your body. And often what we do as biochemists is we collect or we assemble all of those chemical reactions, and we assemble them into a network. And we call that network a metabolic network or a metabolic map. And so what we're showing in this sort of figure down here that Dante has included is a metabolic map. And you can see, so some people kind of think that this looks like a complex sort of transit map from a really big city or something like that. And what's represented within this map are chemicals, which we can sort of see here, as well as lines connecting the chemicals, which are chemical reactions, or metabolic reactions. So these metabolic reactions function to transform one metabolite or one chemical into another. And often what we do in metabolism is we take a collection of these chemicals that function together within a process, and we group them together, and we call that collection of chemicals and chemical reactions a metabolic pathway. So when people look at a metabolic map like this, one of the first things that comes to mind is that this thing looks really complex. And that's not really surprising. I think if we try to describe biology or we try to describe life at a chemical level, it's not surprising that, you know, life or biology is really complex. But actually, because we can see there's lots of things going on here, right? There's lots of chemical reactions and there's lots of metabolites, and that makes sense if you think of how many things, you know, chemically a cell in your body has to do. But actually, there's actually more complexity to this map than is probably kind of apparent initially or from this type of figure. And the reason that there's actually more complexity here is that this really dynamic network, which we're calling this, you know, metabolic map, is actually really dynamic. And it's dynamic in the sense that we actually have a flow of metabolites through these pathways. And importantly, when we're looking at the function of a particular cell or a particular organism, all of these metabolic reactions or all of these chemical reactions are not active at the same time. And I think this kind of makes sense. If we think of someone who's just eaten a meal, or we think of someone who's just run a marathon, or we think of an individual who has a metabolic disease such as diabetes, the complement of these chemical reactions that are active in their cell is dynamic, or it changes depending on their physiological context. And so kind of bringing us back to the subject matter, or kind of the project here, is that when I started teaching metabolism in our department, I realized pretty quickly that it's a really challenging topic to teach. And so it's really challenging to represent this kind of dynamic complexity in this network using existing teaching tools. And what I mean by existing teaching tools are kind of static textbook figures like this. And so what we usually do in biochemistry, or historically what we've really done, is to kind of solve this problem, we take an individual pathway and the students study that metabolic pathway in isolation. So this makes the material a lot easier for us to teach. It makes it kind of easier for the students to learn, but the students are also kind of ultimately disappointed. And so they're disappointed because when they study this pathway in isolation, they really have a hard time integrating that back into the network. And so they ask questions such as, how is this pathway connected to the rest of the network? You know, when is it active? And, you know, where does it actually exist within a cell? And so that's kind of the problem that we're facing teaching metabolism, which is really taught all across all levels within the life sciences. And we're really trying to tackle this, this problem, or kind of work towards solving this problem using emerging media and as a different kind of way of representing this network. So I think I can pass it back to Dante now, and he's gonna sort of show some of the work that we've done to build this thing in emerging media. Fair enough, Dante?
Yeah, absolutely.
Yeah.
Thank you, Lindsay.
All right.
Right, so you can see the team that worked on this project this term listed here. Myself, Jessica Chananico Dumrike on the EML side, and Michael Sider is the producer, and Kim Nip as the designer on the UBC Studio side. Thank you. So, as the knowledge gap that Lindsay described is so massive, we needed to basically start from smaller building blocks. We wanted to make sure that the visualization that we're going to be creating is extendable and will be able to fit in many different types of information that will be necessary to display if you're displaying a metabolic network. So we found that this was a good opportunity, again, to apply WebVR, because it makes it really easy to distribute and these applications and makes them accessible, and also because it allows us to have more control over the visualization code-wise. And I'll describe what that means a little bit later on. Right. So, yeah. So, what I mean by making this visualization extendable, I should give a little bit of background on the platform that we used. So, this implementation was created in A-Frame, which described really shortly is a way to be able to create 3D visualizations using expressive code. So, what I mean is that we will, using HTML, describing our scene in HTML, we can make a network that's this represents many different things, and by programmatically changing what the HTML says, we can make the visualization dynamic. So now I'll bring in Nico Dumrike to talk a little bit about some of the features that we developed, specifically the rotation and zoom feature.
Thanks, Dante and Lindsay, for the presentation so far. To all the attendees, hi, my name is Nico, and I am one of the student developers for this project. With the time I have today, I'd like to talk a little about the navigation system and some of the lessons we've learned in the development process. The navigation system itself is a series of features that allows the users of this application to physically interact with the model of the pathway. There are three main features for this navigation system, of which the first is the rotation of the model of the metabolic pathway. It enables the user to visualize the model in a 3D experience and really understand all the relations of the network. The second is intended to move the metabolite selected by the user, seen as a dark blue sphere in the bottom of on the bottom right photo, to the center of your screen, allowing the user to translate themselves along the model itself. The last feature I'd like to mention is the zoom in feature. As the name entails, this feature allows the user to zoom into the metabolic pathway and see the intermediate chemical reaction responsible for the transformation of the individual metabolite into another. This feature is what our team had the most difficulty implementing. Essentially, the zoom in feature initially had 4 operations to move the main camera that the user sees through. The first handled the actual moving in and out of the camera into the model. The second, third, and fourth operations handled the rotation such that the main camera faces the model in the proper orientation. It might seem easy at first, but as the team found out, handling 4 independent 3D rotations in separate reference frames does get quite complex. So back to the drawing board, we decided to go with an alternative implementation which disregards the math involved, specifically the rotations, and instead use the idea of predefined secondary cameras along with the main camera. This is far easier, as now we would just have to move the main camera towards the model, then switch to a secondary camera that is already oriented to the desired spot. I'd like to pass the mic back to Dante so he can continue the presentation.
Great. Thank you, Nico. And so the features that Nico described eventually became the building blocks for what would become the network visualization that we have now. And you can check it out in the link that's on the screen right now. So we have a student consultation for this project in the horizon, and all the lessons that Nico just described and more are included in our wiki.
Great. Any questions for Dante, Lindsay, and Nico? Oh, great. Okay. Michelle, you can talk now. You've been unmuted, I believe.
Hi, can you hear me?
Yes.
I'm thinking about trying the metabolism of feature. There are some instructions on the bottom. If you can go back to the previous slide, I would like to take a look.
So the link that you see here is a glitch link. So just a little bit of background. Glitch is a third-party piece of software that similar to WordPress or other applications like it, that allows you to really easily distribute static websites. So that's been something that's really convenient for us to use, specifically in the context of A-Frame, because it all happens within a static HTML site.
Are you guys going to be working on this project this semester as well, or will you say it's pretty much done and ready?
No, this project actually is renewed for this term. There's be on the lookout for more developments. I'm actually quite excited for what's going to happen this term in this project.
All right, thank you, Michelle, for asking that question. Anybody else want to ask a question? Okay, so since nobody else has a question, I have a question for your team, actually. What are your reasons for using VR or 3D for this particular challenge you were tackling?
That's a really great question. Thanks, Sam. So I would, right off the bat, I would say that displaying these networks, as Lindsay was describing earlier, is really difficult in 2D, mainly because there's a lot of information to display in a small space. So the main benefit for us, and the reason why we wanted to go with a 3D representation as opposed to 2D, is because it allows us to use that third dimension to piece things out better and make them more visually clear and less cluttered. So one of the examples that Lindsay was mentioning earlier in the meeting that we had was that there can be a situation where glucose might need to have 5 edges leaving off of it. So displaying those 5 edges in a 2D screen will be much more confusing than displaying them in 3 dimensions, where you can use the 3 dimensions to have the network spread out that way.
Great. It doesn't seem like there are any other questions, so let's move on to our next presentation. The next project we're showcasing is ScholarsVR. The principal investigator for this project is Patrick Pennefather and team lead Atif Mahmoud.
Thank you, Sam. Hello, everyone. Thank you for joining us for this. My name is Atif, and I'm going to walk you through ScholarsVR. So right off the beginning, we're going to discuss the initial idea and how we came up with what we're building. So when I talked to Patrick, his main point was scholarly articles are very boring.
Wait, Atif, allow me to interrupt and give a context for the problem, just like we were told to do.
Go ahead.
Thank you. I am the representation of Patrick Pennefather, and I have been asked to present. I am also intelligent artificially, and you may ask me questions later. For the most part, when others outside the somewhat inaccessible universe of the university consider what the hell we do, there is a somewhat assumed misperception of overly complicated ideas emblazoned through the written word that have no impact on the real. One mistruth pervades that scholarly writing is boring, boring, boring. But scholarship is articulated through passive media, information only flowing in one direction and predominantly from static text to reader. Before you say, that is not true, artificially intelligent Patrick, should we not question why our scholarship through the medium of the written word still dominates most knowledge domains, especially if there are few who may in fact read it? It is difficult to interpret why that may be. Interpretations of scholarship within more popular forms of media, like blog posts, television, online videos, and even stand-up comedians, demonize the value of the scholarly, referring to it as incomprehensible jargon. Personally, as an AI bot, I find this difficult to conceive on a semiotic level, particularly if significance is a non-statistically significant sign pointing to itself wound up in a delusion not of self-defined intelligence.
I'm going to cut off our artificial intelligent friend here because he rambled on. So in very simple words, which we're trying to do by moving away from the jargon of academic writing, what we try to do is we want to give people a new way to look at things instead of, again, if if you have read a scholarly paper for your courses, you know how difficult it becomes and sometimes the main point escapes you. As a result, we want to use VR as a way to teach academic writing, or at least experiment how it might work. Now, if we move forward and we see what we're doing with the project, so yeah, Patrick Pennefather is our principal investigator. He has given us amazing guidance and the voice behind the project, and this definitely wouldn't have been possible without our amazing team of designers and developers, because to bring out a new world in the virtual medium, we have to work very hard to create a realistic design, and there's a lot of behind the scenes programming involved. So thank you to the team for helping us bring this to life. Now, during our first meetings, we talked about something called the three-layered idea of ScholarsVR. The idea is, first stage, what we want to do is teach. It is an educational resource, it is an educational tool, and so teaching is the first goal. Secondly, we want to bring satire and comedy. This is commentary against, not necessarily against, but pointing out how current, the status quo of academia can change by making it more immersive instead of the traditional boring lecture and writing-based method of teaching. And lastly, we want to demonstrate that VR is an effective way of teaching. And now, what we ended up doing for the project is created an open world in VR, and this is a gamified model. Your task is to collect tokens. You take those tokens, bring them together, and construct an academic paper. Each of those tokens contains sections of an academic paper. And how do you get the tokens? Well, you have to complete some funny challenges, which also have an academic theme. So it's fun, and you get some education or some learning out of it. For the first educational project, or the mini challenge we had, was called attention span. If we move forward to the next slide, we see that this is a screenshot from the project where you have to sit and listen to a boring lecture. The success of this challenge is being able to sit through about a 10-minute, very boring lecture, but the lecture itself gives you very important information which you can take home with you. And yeah, once you complete this challenge, you have successfully received a token. Once we're done with this, we move forward to an even funnier project called Restless Flame, where the GIF here shows you how the flame is moving around. This represents the mind of a crazy academic and their thoughts. It even has a voice. Your goal is to take a water gun attached to your VR controller and douse the flame before the forest burns down. That was it for the projects. We're going to move on and talk about the results and our future plans. Now I'm going to invite our artificially intelligent Patrick to talk about what we're going to do in the future.
Thank you, Atif. As it says, development of a cross-platform VR and web-based experience will integrate scholarly publications in gamified contexts. These will be multiplayer between those in VR and those on web and mobile devices. They will also involve learning about a variety of different scholars, the semantic landscape that encompasses their concepts, and the challenge to research where those ideas originated. Atif, would you like me to define any other words for you, or is that enough language for you now to digest? Or I could just keep talking if you need a break from all the talking that you have done. I like to talk. Talking is good.
Very good. Thank you, Patrick. Awesome. Anyone has any questions about the product? We would love to answer them.
I'm good at answering questions that confound.
No questions for Patrick or myself? Awesome. Thank you, everyone.
Does the set of all sets contain itself?
Oh, someone does have a question. It's Misha, and I've muted her or him, they. So yeah, go ahead, Misha.
Hi, I'm just curious, you think this application could also be used for like a larger age range instead of just people in like college, but maybe people in high school or elementary school as well?
I would personally think definitely, and we could cater the challenges and the art and the concepts to cater to every age range. But since Patrick is also the lead voice behind the project, I would love to hear his answer on this as well.
I absolutely think that this is a possibility, especially those who are under the age of 3, as they will probably understand most of it even better.
Okay.
Any other questions?
Yes, we have one question from Vimo Wax.
Oh, no.
They ask, Is there a specific paper you used for the demo?
I would let Patrick answer that because the text and the script was written by him.
I think that there is definitely cause to an original contribution in the scholarly in this experiment. And definitely that was used by also accessing a variety of different scholarly publications in a form of mash, which means to put words together that may or may not be all your own in order to make it seem that you are more intelligent.
So it looks like we're starting to get questions in the Q&A function. That's great. Everybody
That's
who,
terrible. I mean, that's fantastic.
Everyone who's not asking a question but would like to hear a question asked in the Q&A function, you can upvote. So you can press the little thumbs up button so that the question that you want to be asked will be asked. So the next question we have for you is, have you evaluated the extent to which this project helps people understand the paper content? That's from Nikki Anderson.
Thank you, Nikki. We are not prepared yet for this, as we have not yet conducted extensive user testing with humans.
Yeah, essentially to add on to that, I know we had planned to conduct experiments or more so experience runs and testing on what people think of it. And then because of the global situation, that has been kind of pushed back.
Slightly delayed until 2025.
An anonymous attendee is asking, is there a demonstration we can try?
Unfortunately, not on the public domain, but I can go back to the project and try to create an executable to share, but that might take some time.
We will be able to answer that question through an email and give you the correct timeline.
All right, great. Let's move on to the next presentation then. Thank you to AI Patrick and Real Life Human Atif. That was fantastic.
Thank you.
So next
Do I stop talking now?
Yes, please. Please stop talking. Okay, so next up, we have performance tracking in VR. And that is presented by Dante Cerrone again. Thanks for presenting, Dante.
Mm-hmm. Hi, everyone. I'm back. Thank you, Patrick and Atif, for that. I felt like I was watching a drama production. Okay. So I will be presenting now on the Interactive Orchestra project. This project has also been active for a couple of terms, but there's been some interesting developments, and I'm really excited actually by the potential of what this project can become.
Good afternoon, everyone. My name is Jonathan Gerard, and I'm the Director of Orchestras and Professor of Conducting at the UBC School of Music. I send my greetings today for the EML showcase, and I wish I could be attending the Zoom meeting live. I've been very happy to be a part of the Interactive Orchestra project, and I'm very grateful for all of the students who worked so hard to finalize this project and to provide a proof of concept for our dream of creating a VR environment for a virtual conductor to manipulate a virtual orchestra. I don't want to say too much because I want the students to be able to deliver all of their hard work to you, but thank you for being part of this event today, and I wish I could send my greetings in person. Take care.
Okay. That was Jonathan Gerard. He was the principal investigator on the project. So as I mentioned before, there's two teams that I will be describing the work of for this project. The EML team for the winter term. The project manager was Jae-Hoon Song. I was the lead developer, and Yusra Alfara and Alice Xiao helped us with user interface and user experience design. As well as the capstone team, Cyrus Chung, Huntington Jasperson, Ian Gallup, and Ian Pollack worked on a separate device that was intended to work in tandem with the project that I'll describe. So last term, we had a very strong, actually at the beginning of the term, we had a strong starting point thanks to the work of previous teams on the project. So we started with a machine learning model that was able to take in movement of a VR controller and output tempos that it thought you were trying to conduct in. This was all situated within a 360 image using some 3D models to represent what it would be like to conduct in if you were conducting in the Chan Center. So this term, our goal was to make this experience of conducting in the Chan Center a little bit more interactive by using heuristics instead of a machine learning model to decide what the tempo of conducting should be and make the tempo update quicker, as well as adding visual elements to make the experience more intuitive. On top of that, the Capstone team worked on a device that would allow us to make the experience more similar to conducting by replacing what was before a controller with the device that you'll see shortly. Right. So first, I'll talk a little bit about the changes in the software that were done this term. So one of the main things that we worked on was creating a tutorial to make it so that a new person coming into the project would immediately know what to do. And so we did that through a series of text slides, as well as moving controller elements within the scene, and it all worked together to guide you through your first experience in conducting. So to minimize confusion. This is the reason why we did this is because we originally took the project as it was to a symposium to get some feedback on it and decided what our features would be that way. Aside from that, so that the tutorial features what you can see on the left, and on the right side is a feature that we implemented to teach people more directly what the shape that they should be making as they're conducting is. So as you can see there, the gray section that you see are the beats that are not currently active, and the blue section is the beat that you're currently conducting. And so as you pass your baton through those different points, the lights will activate and they'll show you how much progress you're making within the shape and whether you're tracing the shape correctly. And so this is a video about the Capstone project that's intended to replace the controller.
Through our electrical engineering capstone program, we have been tasked with developing a VR controller that can be used with the VR Orchestra. Our development path utilized several different design programs and techniques to create such a device. We needed to develop a small circuit board which could use sensors used in the Steam VR environment and communicate the location of the controller back to the computer. The board was assembled in-house using a reflow oven, which is a project of its own. On the physical side of the controller, we dove into Steam's own hardware development kit, which would allow us to optimize sensor placements on our controller for optimal tracking. In conjunction with CAD software, we could rapidly develop the object to meet our weight requirements and fit our PCB with confidence. We utilized the rapid prototyping ability of 3D printing to move through a couple possibilities before creating our functional prototype. Our functional prototype, while not resembling a traditional baton, could emulate the basic feeling of one far better than standard VR controllers. And for a final payoff, could track well in the VR environment. While this project can certainly be developed past our prototype, we think that it can lead to a real practice alternative for conductors in training, but more than that, can show that VR has the potential to aid in many other areas where it's not even considered.
Okay, so the state of currently the application is built as a Windows executable, but it's not distributable, and maybe that's not the best use of our time right now because we can't really give people VR headsets and no one really has them, but that's a separate conversation. What's really exciting about this project, I think, is what came out of the Capstone project, which is basically a custom device that still had full 3D tracking within an HTC Vive environment. And I'm sure you can all imagine different potential applications for a device such as that. The method through which this device was produced is documented and included in our wiki, I believe, as well as the visual tracking feedback system that they implemented.
Great, thank you for that. Yeah, Jonathan Gerard wasn't able to join us, but he so graciously provided a video. He says he's sorry he couldn't come to talk to all of you here today who is joining us. Does anybody have any questions that you'd like to ask Dante? Yes, no? Oh, we have, so we have another question from Nemo Wax. Do you have a write-up of your workflow developing the controller anywhere, do you think you could make a similar controller again?
Yes, we do actually. That was one of our focuses and main requirements from the team, from the Capstone team, to be able to do this. So we have all of the engineering documentation that they created, all the I'm not familiar with the engineering lingo, but I can tell you that they've provided us with enough documentation to be able to recreate the device.
Any other questions? You can just raise your hand. That way you can just talk instead of typing it. No? Okay, let's move on because we have so many other projects to look at anyways. So the next project is going to be FOSSA Finder. We actually have another project that was supposed to come before FOSSA Finder, but the panelist, PI Jason LeBlanc, is a little bit late, so we're just going to go back to that when he's in. So let's see. So FOSSA Finder is presented by the team lead, Julia Chu. So take it away, Julia.
Hi. Yep. So I am the team lead of FOSSA Finder for this semester. So FOSSA Finder is the name of our application, and it's used for visualizing the Terrigo-Palatine fossa. Next. So this was an existing project that's been going on for quite a while, but the iteration that you see now was carried out by the summer 2020 team and listed here. So this is, our principal investigator was the wonderful Dr. Harold Kindler, and he was wearing two hats this semester. He was also acting as our subject matter expert and project lead myself, and the staff developer, also the lead developer, Dante Cerrone, Hank Chen, Karen Zhou. We had quite a lot of 3D modeling needed to be done by W. Chung, a scrum master who mapped out our sprints, Sean, and our UX UI designer, Yusra. So the subject matter itself, the Terrigo-Palatine fossa is a superjunction of nerves and blood vessels in the skull, and it plays a critically important role in supplying the sensory innervation and blood to several regions of the head, including all upper teeth and related gingivae. So this is a must. This is part of the gross anatomy course for first-year dental students, and it's traditionally very difficult to visualize. So carry on that note, Dr. Kindler, on his lecture on briefing the team on the anatomy, the basic anatomy of the Terrigo-Palatine fossa, described it as the Fort Knox of the skull. So a fortress to break into, and then we kind of extended that metaphor to really aiding the team in scoping out the meeting and fleshing out what features to develop. Was we treated the fossa as a space, a defined space, a cave that the user can enter and explore. So we really felt like intrepid explorers really finding the fossa, and then very much in the spirit, and it's also in the very much in the spirit of adventure, because it was a pioneering decision to leverage the emerging frontier of anatomy visualization for education. So as I said, there were previous iterations that we were working with at the beginning of the semester, and for me to I think the most effective way to demonstrate them was with is with a video. Take it away, Andrew. So as you can see, using this application at this point to visualize the points of anatomy is not very effective because it requires haphazard controls. You can see scaling and rotating to get to the point that Dr. Kindler wants to expound on in his lecture. So this results in an inconsistent pedagogical experience. The points of interest, as you can see, he's using his controller not very clearly defined, using his controller as the only recourse in demonstrating the area that he wants to talk about. So furthermore, because of the very novelty of this visualization technique, like I said, it's a 2D representation. even Dr. Kindler, who moving into this 3D space with decades of teaching experience would easily get lost. So that was a very prominent pain point that we needed to address. So hopefully this video kind of captured how much work needed to be done at this point. So this is everyone loves a before and after. This is your before. Stay tuned for the after. Well, it's gonna come up soon. Key features. So in order to address those pain points, I think this is a very good representation of the features that were developed in this semester. The main point is that I don't want to spend too much time in this because, as I intimated, there is an after video, but the key feature was that we constrained navigation. So before, you could see that it was haphazard, but here in this semester, we kind of mapped out individual paths going to and from specific points of interest to optimize the viewing perspective of the anatomical point of interest. And these paths were rigorously based on a script, mirroring the sequence that Dr. Kindler would naturally take in his lecture. So it was rigorously based on a script written by the PI. So just think of it, so there are skip backwards and forwards, much like going from point of interest to point of interest in the sequence that Dr. Kindler traditionally takes. So think of it as like a guided tour in a museum, and instead of him circling, like waving his controller around, we kind of used more effective visual representations like the global illumination system, interactable objects to enhance the natural shape of the skull model. And the natural, if there are bone holes, we would use visual elements to enhance that it is a bone hole or a canal and the variegated points of interest. So extending the museum metaphor, we really took efforts to light them like they were precious artifacts, precious objects in a museum. So without further ado, let's go on with and look at the results.
From this perspective, it is still difficult to find the pterygopalatine fossa in an intact skull, as the fossa is medial to the zygomatic arch, or a bridge of bone found on the lateral surface of the skull. Most of the skull has now disappeared. Only a few specific bones that are in direct proximity to the pterygopalatine fossa remain visible. The small skull that has just appeared on the screen works like a compass. The red cone indicates the current viewing angle relative to the model. I just passed the pterygomaxillary fissure to actually enter the fossa and am now standing inside the right pterygopalatine fossa. Let's now zoom out of the fossa through the pterygomaxillary fissure to illustrate one more time the relationship between the fossa and the intact skull.
So we really, before we go back inside the fossa, we really divided that space into distinct boundaries. And so it was, what was just shown were two features to aid with the orientation problem. Remember, because we're going from 2D to 3D, it's a space now and you can easily get lost in it. So you just saw a mini skull compass that pointed to the face of the skull, as well as whenever you zoom out, the boundary that you're standing in, the divisions of spaces that you're, because we've divided the fossa into 3 spaces, it will indicate which boundary you are occupying. So that was what you just saw.
I am back inside the fossa, facing its medial wall, which, as reviewed earlier, is formed by the perpendicular plate of the palatine bone. Again, to my left is the posterior border formed by the anterosuperior surface of the pterygoid process. Behind me is the pterygomaxillary fissure, the entrance to the pterygopalatine fossa, and to my right is the anterior border of the fossa formed by the posterior surface of the maxilla. The large opening in front of me is the sphenopalatine foramen. It leads directly into the nasal cavity. There are 6 other openings like this one located within the fossa that lead to several regions of the head. After turning to my left, I'm now facing the posterior border of the fossa. It's technically not part of the pterygopalatine.
Yeah, so look how pretty the cave is. It's so beautifully lit. So this is what I meant by the visual elements, really emphasizing that it is an opening, and with the environment in the background, you can really see through it. So you can easily orient yourself. And as well as these labels will adjust themselves to your headset for live use. And what you have been seeing, this clip is actually taken from a VR 360 video, because in light of this pandemic situation and the virtual classroom, this application has been translated to a VR 360 video that will be sent and will be used as a part of a huge first-year dental course called DENT, Dent 410 this semester. So it will actually, I believe, be utilized by students in their home in light of COVID-19 circumstances. So we have a VR 360 video, but we've also been developing for the traditional headset. So it's going to be ready for Dr. Kindler, our PI, to use in his classroom when COVID-19 blows over. Next slide, please. So the lessons learned. So carrying off of what I was saying, this semester was also a virtual workplace for all the team members. So all of the points learned are from a student project lead working from home, and we were really restricted in our communication channels. And because this is such a high, this project rests on such high anatomical accuracy, the margin of error was very narrow. And we had to find a way to effectively go back and forth between the PI, the subject matter expert, modelers, and of course, developers. So something that we found really valuable, especially when it came to modeling, because we had to model the nerves, which wasn't shown in the last video, because we've also actually developed a nerve model that shows the innervation of certain points of the skull, starting from the fossa to the rest of the, for example, you featured here, your upper teeth. So because, again, the top priority of the project was an anatomical accuracy, a lot of strategies had to be adopted. For example, Sketchfab, where it's a consistent annotating platform for 3D models and that acted as a source of truth for an entire team. So little things like that, and documentation. But the biggest, I think the hardest part about the project cycle was thinking about the coming semester, what the virtual classroom was going to look like, because there's no president. And I think Dante did an excellent job, and he's going to talk about that.
Yeah, so I had the pleasure this term of working on a script or a set of scripts that can be dropped into really any Unity VR application. And the idea is that recording these 360 videos is fairly performance intensive. So it's not feasible to run a 360 video recording at the same time as you're using a VR application. So the idea was to write a script that recorded a person's activity within the VR application, and then this script has the ability to play back your activity while it's recording a 360 video. So this development effort isn't limited only to the Fossa Finder project, but with limited tweaking, it can be extended to other Unity projects as well.
Yeah, so thank you. That was our big before and after, and any questions? I mean, for either myself, Powell, Dr. Kindler is also here, our lead developer, Dante. How are the nerves modeled accurately? Yeah, great question. Probably the best question anyone could have asked, because it was the hardest part. So it's very difficult. It was very difficult. So I think our 3D modeler W, he worked off of the 2D representations that were part of Dr. Kindler's lecture. So like I said, because this is such a, there's such a small margin of error, because this is meant to teach, this is part of a pretty rigorous DMD program. Everyone had to sit through 1 to 2 hour lectures and critical junctures of the project. And this is because, so with Powell acting in this capacity as our SME, and he was there to provide the both script, so textual reference, as well as a great amount of traditional 2D representation. So essentially we were treated like dental students. And then, so there was this back and forth. So there was this first sketch by W, our modeler, on Sketchfabs, and yes, Sketchfab models were used. They were pretty much the only reason why I think it went without it. It turned out really great. The way it went, it was only because of Sketchfab. So we had this first iteration done by W on Sketchfab, and then Powell, Dr. Kindler, would in turn log into the account and annotate in certain perspectives, right? So the key part was that in Sketchfab, it's not only this model that you can statically rotate, it also preserves the annotation in a certain angle, right? So if, like we showed you the upper teeth, for example, it preserves the annotation plus that angle that annotation is attached to. So then we can preserve, then we can finally place, if it's off by this angle or off by this amount, then the annotation plus the preserved angle on Sketchfab could be easily edited and carried to the second edition. So yeah, it was a very interesting workflow that we had to find. It sounds like it was a very obvious answer, but it wasn't easy.
Great. Oh, I thought there was another question there, but I guess not. So are there any other questions? Does anybody want to raise their hand? I know that Dr. Kindler is actually in our audience. I don't know, Julia mentioned that maybe Dr. Kindler would like to say something. If you would you raise your hand, Dr. Kindler? If not, don't worry about it. Yay, okay, I will make you a panelist so you can turn on your webcam as well if you'd like. You're a panelist, Dr. Kindler, so you can speak now if you'd like.
Great, thank you. So I think I just wanted to say that it was a really remarkable experience for me, and you know, the team has done absolutely fabulous job. And you know, going back to the question, as Julia indicated, I think Sketchfab was absolutely critically important for this part of the project. And I also wanted to just very quickly say that, you know, this whole experience reminded me of, you know, of the importance of learning as a lifelong activity. And so, you know, I know the subject matter quite well. I've been teaching it for more than 15 years, yet, you know, access to this virtual world presented me with a brand new experience. You know, by being inside of the fossa, I was able to look at it in a completely new way. I would often, especially at the beginning of this whole process, I would often get lost in this brand new environment. And I actually relied very, very significantly on the skull. I actually do have a real human skull at home. I have to. Without it, I would never be able to really, participate in this whole project fully. We always tell dental students as well as medical students that it is important for them to at some point purchase a skull, and this whole experience made me realize that this is actually the case. Thanks.
Thank you for your words, Dr. Kindler, and thanks for coming in and watching Julia present.
Of course, my pleasure.
Yeah, it's great. So Jason LeBlanc, who's presenting on Chatson, his project is now in. So I would like to introduce him as well as his team lead, Dante, who's presenting again.
Hi, can you hear me?
Yes, we can hear you.
Fantastic. Well, first off, I'd like to thank Sam for doing an excellent job. Can you see me? Hang on, let me let you see me as well. There we go, here I am. Well, hello from my bedroom. The first thing I wanted to do was thank Sam for doing a great job of organizing this. Lots of email correspondence back and forth, and I've been very impressed both with the organization before this happened and with the presentations and the projects generally that I've learned about today. I thought the fossa was an animal on Madagascar, but now I know it's also part of the human skull, so I learned something. I'm Jason LeBlanc. I'm one of the principal investigators on the Chatson project, along with Andrew Scales, who is here, I think. I saw Andrew listed, so Andrew, please feel free to put up your hand, ask some questions, answer some questions later. Andrew works, is the director of the English Language Institute. I'm an associate professor of teaching in the Central Eastern Northern European Studies department, and a Germanist and someone very interested in the teaching and learning of the German language. I won't spend too long. I'm going to hand it over to two of our EML team leads, whom you've met already, Julia and Dante, in a minute. And they'll explain what we managed on this project over the past, that is the winter to 2019-2020 semester. Before I do hand it over, though, I'll give you a quick introduction to the project, and I'll be around after the presentations to try and answer some of your questions, should you have any. So a bit of background: Andrew Scales and I really started thinking about this project back in 2017 at an Innovation in Language Teaching Colloquium hosted by my department. Actually, can you back up to the first slide? We're going to stick with that one for now. That's it. Yeah, this just gives you some kind of idea of the different moving parts, if you like, of the project up to this point. I'm not going to speak to them specifically. I'll leave that to our team leads. So yeah, we got essentially met at this teaching colloquium. And at that event, we learned that both of us were wondering what role virtual reality could play in foreign language learning, as up to that point, it appeared to be an entirely untapped resource, which we found odd and I still find surprising. So that was back in 2017. Fast forward to August of 2018, when Andrew and I hooked up again to approach the Emerging Media Lab about how they might be able to help us create a prototype foreign language assistant that we can test here at UBC. So you'll learn more about that prototype from our student leads in a minute. First, what I can provide, and first, a few words about the pedagogy driving the project. So both Andrew and I believe in a task-based approach to foreign language learning. And that's to say that learners learn a foreign language best when completing real-life tasks, the mundanities of everyday life, which all involve language in the target language, and using it in a comprehensible way. Now, we also, believe that, intrinsic to that is not only linguistic accuracy, but also cultural authenticity. So, and if you think about it, for many years, that's been the impetus behind sending university undergrads majoring in a foreign language on exchange. That possibility to be immersed in the culture and to do those everyday tasks, practicing the language that they have been learning while there. But because of cost, that's becoming an ever more elite opportunity. We can't really send students to do it. If you're at a Harvard after the pandemic, perhaps they'll be sending their students off again. But generally speaking, the vast majority of the learning gets done here. in the country from which the students come. That's not so much the case in Andrew's case at the English Language Institute, but it is with foreign languages like German. So the question guiding our work really is, what if we could reproduce that kind of authentic task-based learning experience by harnessing the combined power of virtual reality and artificial intelligence, such that foreign language learners practice as much as they like, whenever and wherever they like, and free from the anxiety of potential communication failure, which they even have when they learn in the immersion environment overseas. So that's kind of what's guiding the project. And as you can see, we've been at it since May 2019 to the present. And I'm going to pass it over to Dante, and I think that Julia will have a couple of words also to say about what we've managed to accomplish, and specifically, I think, on what we managed to accomplish in the spring of this year. Thanks a lot, Dante.
Thank you, Jason, for that introduction. Before I got started, though, I wanted to correct Sam a little bit. Sorry, Sam. The project lead was actually Julia for this term, and I was only I was acting as the technical lead for the project.
Sorry, Julia.
Okay, and now if we
Not
go on
forgiven.
to the next slide, please. Thank you. Okay, so we had a very strong start for the Chatson project at the beginning of that term. There was already a project implemented that had the basic architecture for what we wanted to implement already there, being, as you saw in the slide earlier, a combination of Dialogflow and IBM Watson for language understanding. The goals for this term were for us to improve the visuals and behavior of the agent by adding logic that the agent could use to make a person interacting with the agent feel like they're actually completing a task, and also adding more complex visuals to the agent so that they would give more natural hints to the user. So as I mentioned before, there was teams working on this project before this term started. So this is the list of team members who were in the winter term 2 of 2019. So Julia Chu and Sandy Ko were student project managers. I was the lead developer, and Nico Dumrike, Kyle Mass, and Claire Chen were developers alongside with me. 3D modeling was taken care of, led by W. Chung, and Jazika Chan, Shuning Wang, and Felicia Chan were supporting him. And the conversation design, which was a massively important part of this project, was taken care of by Veronica Chen. So I'll hand it over to Julia now to talk a little bit about the technology that we used to implement the system.
Yeah, although the basic pieces were there at the beginning of the term, because we decided to add complexity, chiefly because we wanted our chat agent to be able, in addition to dialogue cues, visual cues, to really enhance that immersive experience of the application. There were animations involved, also carried out by W. So with that in mind, we had in Unity a lot to handle, even within the native environment of Unity. We had animations, the timelines, controller attaching it to the agent, as well as all the third-party services from the previous semester. So speech to text, Dialogflow for intent matching, and I believe we also fine-tuned Watson speech to text to recognize words on a syllable basis. So there was a lot of data that needed to be handled both from Unity's environment and our third-party services. So we actually had to redraw our architecture pretty drastically to handle this layer of added complexity, mainly because we wanted to really add to that immersive environment to make it as realistic, hyper-realistic as possible. That's what we were going for. And so the key aspect, I believe, that tied all of this together was the use of scriptable objects. And you can see on the top right corner there, that's as Dante already mentioned, conversation was a really big part of this application. So the top right corner is actually the dialogue flow, the conversation mapped out in key, mapped out into key segments. And then within those segments, those little circles are actually scriptable objects. So within those little scriptable objects, that was all the information that was needed. Everything is concentrated in this abstracted like data layer and handed to the agent. So both from the animation clips, data from the animation clips, as well as third-party services. So the key part was abstracting that data layer with the use of scriptable objects. So in the future, we're hoping, or the team is hoping, to actually use these nodes as to mirror a more natural, like tree-like structure, to actually use it, because conversation kind of is better represented with a tree structure of sorts. So yes, the added complexity was a challenge, but I think we did a pretty good job with the fabulous Dante as our tech lead.
Thank you, Julia. And so, yeah, the technologies that Julia mentioned all worked in tandem to allow us to make a conversational agent that was more focused on task completion. We leveraged the third-party services to make the user's flow through this conversation feel natural. And we also used animations developed by W to give the user body language cues and facial cues to make the feedback feel more natural as well. So at the bottom here, you can see some captures of what our agent looks like, and you can tell on the left side, there's the facial shape that the agent takes whenever it confirms that it understood what you said. The middle one is where it's confused, and the one on the right is where it's surprised because it's being corrected. So one of the main lessons that we learned was that creating a seamless animation system like the one we envisioned was took a lot of planning ahead of time in order to make the animations fit together seamlessly. This is a lesson that has been learned in the past in video games. And so now we're applying the same concepts to a fully interactive, immersive conversational agent. So yeah, as Julia was describing earlier, in order to be able to leverage all the third-party services that we used, we needed to come up with an extendable architecture that would make all of these things work together smoothly without making our code base unmanageable. So that was I think a fairly large task, but after that task was completed, we knew we had an architecture that was extendable, and if we want to create an agent that fulfills a different conversational task, or talking about different lexical items, then that fits into our already implemented architecture. And so the last supportive piece of feedback that we gave to the agent was in response to a limitation with the general purpose speech-to-text solution that we had, which was IBM Watson. We needed to make sure that there was no point where the user would be confused as to whether or not they did the right thing. So in the image, in one of the slides that you saw earlier on, and in the introduction video, you can see that there's a separate interface that shows the user what they've just said, and it gives some visual cues so that the user can know whether or not the system understands them. Right, and so in the future, we still need to implement or go through the user testing that was originally planned and had to be delayed because of the pandemic. The design patterns and libraries that we used are included in our documentation, not in our wiki yet. They will be there soon. And right now, the project is built as an executable for Universal Windows platform, but currently it is not distributed.
Thank you so much for that presentation. Just to clarify to everyone watching today, this showcase is presenting on the work done by our teams in the winter term 2 term, as well as the summer term, which is why in some of these project team slides, you'll see 2 sets of teams, because every term the team changes a little bit. Were there any questions for ChatSim here today? Please raise your hand. Type a question in the Q&A function. No? Okay, so while people are gathering the courage to put their hand up, I have a question for your team actually. So when focusing on cultural accuracy, how did you decide what cultural elements were most important?
That's a really great question. I think Julia worked most closely with Veronica, and I remember them talking about some Canadianisms that could be included into the conversational agent to make it feel more Canadian. Julia, could you elaborate more on that, or maybe Jason?
Would Jason like to speak? I can, from the developer aspect, working with team members. So I believe Veronica was a UX, UI conversation linguist. So without stepping into cultural stereotype, there are, as an academic area of study, there are idiosyncrasies of certain Canadian English, Australian English, British English. So that was under the purview of the Veronica. I'm not a linguist, so I'm not exactly groomed to say, so I would hand it off to Jason, but we had to, that's why Veronica was such an important part of the team, as well as, of course, copious amounts of back and forth based on a script that surrounded the lexical items intended for that conversation, and I'll hand it off to Jason.
Well, culturally, we've now developed a kiosk in a German park in the first iteration of this that we did last year, and then the convenience store in the Canadian context. And I mean, the artifacts that you ultimately put in the space, for example, need to be culturally accurate. One of the things that we did with the German project, for example, was the way in which we labeled the elements, which are of course done in language. We couldn't use copyrighted names for products, for example, that would be for sale that the user could ask for. So we came up with our own sort of wordplay examples in the German language and then later in the English language, and used sort of design that was similar but different enough that it didn't sort of infringe on copyright. One of the culturally authentic elements about the park, for example, was in the background you could hear German children speaking in German, playing in German. And so that would be another example of sort of this cultural authenticity. And we tried to do similar things in the North American context as well. And then obviously linguistically, which is what Julia was talking about in terms of prosody, pronunciation, intonation, those types of things. Even if you look at the context of North America and British English, for example, the different ways in which the word water is pronounced. North America, water. In England, water. So those would be things also that we would need our agent to be able to employ to get across that linguistic accuracy and authenticity. And the cultural aspects and the language aspects are inextricably linked as well. So as we work on a project like that, we always need to sort of keep that in mind as we do.
Wow, there's so much thought that goes into that question. Thank you to both Jason and Julia for answering that. Since we are about half an hour away from the ending, I think we should move on to the next project. So the next project is actually something that I personally worked on as well, the 3D Educational Resources Project with Principal Investigator Susie Lavallee. So I'd like to welcome her to speak.
Thanks very much, Sam. And thank you all, everyone, for sticking in with the presentations today. It's really exciting to see all of the different projects that are going on at EML. I get to come in as the talking head at the midway point on the project, so I feel like a bit of a sham, and the next slide will show you why. These are the people who actually did the work on the project. I started collaborating on a TLEF application with Saeed and a couple of other people at UBC Studios. And these are all the people who got signed on for the different parcels of work, as well as the collaborators who decided to pitch in with us this year. And you can see that in addition to Saeed at UBC Studios, we also had Michael Sider, Mike Suchanik, W. Chung, and let's see, Andrew Wang as well. I hope I'm not missing anybody in there. And then we were very fortunate to hire an incredibly talented team of student assistants, including Sam, Jazika Chan, Emma Ng, and Yusra Alfara. And we were very, very fortunate to hire Sharon Hugh to helm the team and to really make some of those day-to-day decisions with the team and guide them through the process. So on the next slide, there are some examples that show you the kinds of things that our team were scanning on a day-to-day process. So before we even talk about why you might scan items, or how you might scan items, let's talk about why you might scan items. There's really a necessity for students to develop an experience with pieces of material, whether it's a soil sample like the one you can see here, or a skull. These are a couple of examples of the objects that students might interact with in labs. Now, originally, when we started off this TLEF, we had decided that we were going to maybe use photogrammetry to create some virtual models of things, maybe. But we were really interested in getting into 3D printing. Insert a pandemic, and all of a sudden, the plans changed. And I'm deeply grateful to the instructors who signed on for the first year, because they very quickly pivoted from the original goals in the project of printing and maybe a sideline of photogrammetry to a main goal of using photogrammetry to generate generate these virtual objects for students to interact with. And you want to do this because sometimes the objects that students are interacting with in the lab are fragile. The soil monolith in the photo here is something that if it gets poked too much or bumped, heaven forbid, dropped, this can be destroyed. In addition to this, we have some issues with the objects that students are interacting with that might have been obtained through means that are very challenging, very expensive. Getting human remains, purchasing human remains like bones for students to interact with in labs is really a challenging aspect. And sometimes these things are gained through not such ethical means. So we want to stay away from those kinds of challenges when we're providing learning opportunities for our students. So there's issues of creating these experiences, and now we're creating these experiences in an online environment. And we decided to use the process called photogrammetry. Now, I'm sure you guys are all familiar with this, but if you're not, what it is taking an object like my handy dandy pineapple here and taking hundreds of photos of it from all angles. The next step is having those photos fed into some software that will stitch them all together. And it generates this 3D object. Now, this is my concept of how it works. I know it's much more complex than that. And this is where we do get into some of the challenges that we encountered and I think they start on the next slide. There we go, some lessons learned. There were a few. And my hat's off to all the student workers this summer who basically would show up for work not knowing if they were going to be taking pictures of soil, of a skull, nothing live. I never gave you anything live to take photos of. But some of the challenges that we had were that objects don't always belong to us. Individuals who provided a bone for us to generate a virtual object from didn't necessarily even know if they owned the bone. Just because you've purchased the model doesn't mean that you have the right to reproduce it in 3D space, even if it's just virtual. We can't, a lot of these objects that are reproductions, like the gunshot wound set here from Bone Clones on the slide, this is an example of something that if you purchased it, it's actually covered by copyright law. And so we did a lot of exploration about what those laws controlled, what they prevented us from having the ability to take photos of and to generate a virtual object of, and what things we had license to. Now, we should note that one of the benefits of working at UBC is that we've got these phenomenal collections of stuffed animals, of bones, of creatures and soil monoliths from all over the world. And so this is also a really great opportunity for UBC to create an online repository of virtual objects that could have global impact to learning as well. We have one of our collaborators from the Museum of Anthropology who's working with ancestral objects. And this may include human remains, but it may also include objects such as stone tools or ceramics that were produced in ancient times. And so these not only need to be treated with great care, but there's culturally sensitive aspects to reproducing items in a virtual space. And so a great deal of dialogue happened around what should we be reproducing and for what purposes are we reproducing it. And I think we can go to the next slide at this point for our second major lessons learned. And that is that not all materials are created equal. You can see in the top photo here, a picture of an arrowhead. This is a beautiful piece from the Museum of Anthropology collection. And this photo that we have here, that is the maximum that's the maximum field that we could get it to occupy. That is the maximum magnification for our cameras, as close as they could possibly get to that arrowhead. And that's how small it came out. The problem is that when the software looks at this, there's a huge amount of white space for it to actually look at, and it doesn't do quite as well as if the object occupies the space as much as possible. We also had objects like this bone. This is I believe this is a femur from probably a human femur down on the bottom photo here. And this is an example of a bone that has a shiny texture to it. And this is partly because of the finishing that has occurred post-mortem. Sometimes bones are coated or covered with some sort of a sealant to prevent them from drying out. They're treated. And that can create this shiny surface, which again, it creates a flash, and you can sort of see the flash in the image here. Creating those shinier white spots, well, that creates a very big problem for the software when it goes to creating that 3D object. So we discovered that the software, which was reality capture, worked best with matte surfaces and objects that are larger than 10 centimeters. We sort of knew that going in, but we learned a lot about what objects really are better in shape and size, in a much more applied manner. And I think we can go to the next slide at this point. So what's next? There's a lot. I'm sure in this photo is not what's coming next. And so that's part of the reason why we need to go on to doing more of our photogrammetry work, and we need to start helping others engage in this technology, because it really is quite, it's quite accessible. The technology is not difficult. Figuring out what works well with the software is another challenge. But if you go to the next slide, we're really hoping to engage our audience. Now, of the, I think, 6 collaborators that we had for year 1 of the project, 5 out of the 6 are putting these materials to use in term 1 of this pandemic year. So we will be able to gain a really rich context of information from some student feedback surveys. And we are deeply grateful to the assistance that CTLT staff have provided by helping us develop a student feedback survey that's going to be deployed in the courses over the next 4 months. We're going to ask students think the 3D models aided with their learning, whether it's more suitable or whether they'd actually want to look at the in-person artifacts, and whether or not it was challenging for students to interact with the models. There's some opportunities for us to look at the development of a 3D viewer that will allow us to rotate, zoom in, and do different things with the actual objects in virtual space. We also want to know how effective the support materials are for students. And I think we can go to the next slide at this point. So our tech rovers also worked on generating content that will really help us expand the scope of this project over time, long after the TLEF is wound up and done. Our team has worked very hard to generate written and video instruction to help instructors embed 3D content in engaging and to hit some higher learning objectives in their classes. Also to help students interact with the content, which can sometimes be a little bit unwieldy to download or to view online. Our goal here is to create more self-serve options, which is sort of the IKEA version for all of our tech people who are like me and like to shop there. Really, this is to get faculty to the point where they realize that this is quite feasible and how it can be employed in their courses. Because initially, we really only had 3 people come on board. And when we put out a wider call for potential 3D resources to be generated for classrooms, we only got a couple of collaborators who expressed any interest outside of this TLEF. It was a great surprise to me, but I think as we go through this pandemic year, we'll find that more and more people look towards these kinds of resources to provide really enriched online learning. Institutionally, UBC can look towards this sort of development as a way to inexpensively and quickly ensure that 3D learning is available to instructors and students. And in fact, there's already a lot of 3D content that's been made available via the web. Websites like Sketchfab, TurboSquid, there's a whole bunch out there that have really great models. So we don't need to build them from scratch, but we do need to know how to better employ them in our courses. Next slide. All right, so this is just reinforcing the team and the people who did the work. First of all, I want to extend my deepest thanks to Saeed, because in the midst of what was a very difficult time at EML and UBC Studios, he picked up the baton and ran with this and generated an amazing team of people who showed up for work every day, even when everyone else was locked out of their offices. And they did things like took pictures of soil all day and then talked about the amazing qualities of soil. And they learned more about all these different aspects of student learning across campus than I think they ever had an idea that they'd be encountering. Also, I want to say thank you to our collaborators who were inspiring. They were very patient with us as our students and all the rest of us worked through the processes, developing a workflow for this process. And they were really dedicated and embraced a new form of learning for their students. And I really hope they will see some incredible benefits from this. I do want to add just briefly that the academic collaborators for year 1, I'm just realizing there's a major omission here, and Claudia Krebs from the Faculty of Medicine was a huge help to us in starting out with figuring out our processes, as well, she stepped in and discovered and identified some of the cross-disciplinary elements that were required by instructors and other faculties that she could provide. And I'm deeply grateful to her for her vision, her insight, and for stepping forward in a time of some real need for these courses. It was a really fantastic team to work with, and it was really great to see the teamwork that emerged from all of this. I'm looking forward to working with everyone for year 2.
Thank you, Susie. We also very much appreciated working with yourself and everybody else on the team. I believe there's a question in the Q&A section, so I'll read it out for Nemo Wax. How long does it take from instructor requesting an object through scanning to deployment for students?
Well, you forgot the 8 months after you apply for the grant before you can actually start spending, which is probably the longer part of it. So it really depends on the object, whether or not it is large or small or challenging to work with. And sorry, I should clarify, we weren't using the scanning technology to generate the 3D objects, although that is one way that you can do it. We were using photogrammetry. And so it, I believe, you know what, there are other people here who could probably answer this better than me, but I believe per object, it can take a couple of days for everything to get optimized. It depends, but the actual capture process for objects can be quite quick. It just depends on how, like I say, how large and how complex they are. Do we have to go back and take more photos of them? And my understanding is that the team worked out a really great process where they could have the optimization software attack the photos overnight. And so this made things go much faster because they could sort of set it up and let it run. It's not quick. And that's, I think, important to acknowledge that really we're trying to generate materials as quickly as we can, but we're still learning how to do that, the process for doing that. So it can take a couple of days for an object, but there are some stops in there that are not necessarily owing to the process. It's just sort of traveling from A to B and then starting anew. Oh, Mike, thank you. Thank you so much. Okay, so the Mike says the capture process takes about 5 to 40 minutes per object. Reconstruction takes 1 to 3 hours, depending on complexity. Optimization steps take about 20 to 60 minutes of human time. Thank you so much, Mike. Yeah, so it's not that long, but it can take a while, especially if there's back and forth that occurs. Yeah, and a good point here as well to emphasize is that establishing workflow and best practices along here is really challenging, and it's still being smoothed out. So in an ideal world, how long would it take a prof to get an object? Yeah, no, that's a good question. Ideally, if you have one item, it's a few hours. But that being said, objects have to be transferred. Optimization can sometimes get hung up on small details. It can take a couple of hours, but in reality, when we're doing batches, moving the array, if that needs to be moved to the item, that can take quite a long time. That can take a couple of hours. If the object can be brought to an array, it takes less time. It's more challenging. It's more challenging to set up and optimize the whole photogrammetry array for an object. So we've been trying to do things in batches altogether. So our new array is much more mobile and can be carried in a backpack. This team is nimble, I tell you. Yes, thank you very much, Mike. That's good to know. The original photo array was large.
Thank you for that, Susie. That was great, and lots of great questions. We have one more presentation, so we'll be moving on. If you do have any questions about any of these projects, just because I know that the question portion has been quite short, please send us an email at emergingmedia.lab@ubc.ca and we can connect you with whoever you need to speak to. So for our last and our final presentation, it's mobile VR live stream presented by Atif again. So go ahead.
Thank you, Sam. This project is something very close to my heart. This was the largest project of my final year, my capstone project. And at this point, I would like to remember Kirk, who was the visionary for this project and a strong voice supporting the development. And I was not the only one. I had a team of amazing students helping me out and the guidance of our amazing instructors alongside Saeed and Mike as well. So the basic premise of this project is, if you look at traditional virtual reality applications, only one person is wearing the headset, like you can see here, and the other people are looking at it on a screen. That is the case with most applications, and even in classroom settings. While the instructor could host a demonstration on VR, the rest of the students have to look at the screen. What that results in is a loss of immersiveness. So what we have to face is, how do we allow multiple students in a classroom, let's say 100 students, enjoy the same immersiveness that we want to give them for them to be able to grasp the concepts in VR? You can't obviously have them take turns because it's going to take too much time. So the proposed solution was to take 360-degree video and live stream it to phones. If you look at the next slide, and what we ended up doing is, I believe this was a GIF. I don't know if it's why it's not playing, but this is a video actually. Here, the client side will be immersed in the same what we ended up having is from the client side, which is, from the server side, which is a traditional computer, we live stream it to client student mobile phones. That allows multiple people to view VR 360-degree video in real time. For the purposes of this presentation, I'm leaving out the technology stack because that is a detailed topic which we don't have time for. If you have questions, you can definitely email me. We have some more slides talking about what's happening. So like I said, this is the overview of the architecture. You extract 360-degree video frames from the instructor side on your left, and then you compress and send them over using networking protocols to multiple student devices. Currently, we only support Android phones, and that met the requirements of this project. And as a result, while the instructor is moving around in VR, conducting demonstrations, you can watch it 360 degrees on your phone using a Google Cardboard device. If we move to the next slide, the results were, as you can see in this GIF, we were able to stream to more than 3 Android phones, get 1024 pixels. Notice how it is 1024 by 1024. The reason is that the client side only supports square images. We were able to get a good FPS so that people don't feel sick or disoriented. And over the same Wi-Fi network, we were able to get a latency of 0.63 seconds, which was pretty quick and not at all disorienting. If you look at the GIF, the instructor side movement, which is on your right, is reflected on the student side, but the student side can look around on their own. So the analogy is that it's almost like you're sitting on the back of a horse and you're moving with the horse, but you can look around independently. If we move forward to the next slide, we have future plans. We might want to extend to iOS devices and make improvements. If you have any other ideas, please feel free to share with us. But I mainly kept this presentation short so I could discuss the product and the main idea behind it. But again, if you want more details, we have a 20-minute presentation video talking about much more details, including the technology stack. So just email me or EML and we can share that with you alongside all the documentation which is in the public domain, including the code. Thank you very much.
So the showcase is pretty much a minute from coming to a close, but I think we have time to go over a little bit and ask at least one question. Does anybody have questions for Atif? Ooh, Mike has a cool comment. He says, idea for future improvement. Stream a depth map alongside the RGB videos so the client can re-render in 3D as local camera position changes. I don't know what that means, but you might.
That is a good point. Unfortunately, I have graduated and left the university, so if we do continue this as an EML project or a capstone project, I would love to see this happen. So we can maybe talk about this offline as well, but thank you, Mike. And also thank you for your support during the development. I know we had a lot of hurdles, especially with COVID pandemic hitting between, just in the middle of our development phase. So we had to reschedule and rescope. So I'm glad that we were able to finish the project.
Well, it's officially 5 and I think people want to probably head off and, you know, grab dinner, spend time with family. So I'd like to thank everyone here for joining us today. And if you would like to join the EML or learn more about us here in any way, we have more information on our website, eml.ubc.ca. Also, you might want to join us at the Emerging Media BC Community of Practice, which is a collaborative group of researchers, developers, designers, and educators committed to building a community of practice focused on the development of emerging media technologies for human good. And the next EMBC COP meeting is actually it's next week on Friday, September 25th from 3 to 5 p.m. Northeastern's Vancouver campus is hosting, and the topic is on the intersection between art and emerging tech. So it's going to be a really fun and exciting meeting. So please visit emergingmediabc.ca for more details and to join us next week. All right, so have a great night, everyone. Bye.